types of special parallelograms. We have our rhombus, rectangle, square. But once again, in order for it to be a square, it needs to be both a rectangle and a rhombus. It has to meet both those requirements in order to be a square. While a rhombus just needs to meet the 4 sides, a rectangle just needs to meet right angles. Now, we have a couple ways of proving whether something is a rhombus or whether something is a rectangle. This time we have those 5 ways of proving whether something is a parallelogram. If you have a parallelogram and you want to show it's just something a little bit more, we can use, I think the line disappeared. Alright, so if you're trying to prove that a rhombus, or if you're trying to prove that a parallelogram is a rhombus, all we have to show is 2 adjacent sides are congruent. So if you think about it, normally with parallelograms, the opposite sides are always congruent. Every normal parallelogram should have that. But if you can show that 2 of those adjacent sides are the same, that means all those other sides would have to be the same based off your opposites. And so, just by showing 2 adjacent sides are congruent, automatically makes it a rhombus. So you just have to find if this one's 5 and this one's 5, boom, you're done. You have a rhombus. For showing a rectangle, all we have to show is just one 90-degree angle. If we find one 90-degree angle, that makes your consecutive angles 90 degrees, and it makes your opposite angle also 90 degrees, because we know consecutive angles are supplementary, opposite angles are the same, and so all of those would also have to be. So just by showing one 90-degree angle on a parallelogram, you show 4. And so rather than having to look for all of these things, we just want to find the bare minimum to show that this is a rectangle or this is a rhombus. And then the last one, if you want to show it's a square, you have to show all of it. You have to show that you have 2 sides that are adjacent, that are congruent. You have to show you have 90 degrees, so it meets both those requirements in order to be a square. So squares take a little bit of extra work, but typically when it looks like a square, you can assume, okay, this is going to be a square. I know what I need to look for. I know what I need to go down to be able to solve it. It just takes a little bit extra to get there, because you have to show more than just one thing, more than just 2 things. So with all of these, we're going to be dealing with parallelograms. You already know it's going to have a parallelogram. You know it's going to be that. You don't have to work from a quadrilateral up to a parallelogram, up to a rhombus, up to a square. You know it's going to be a parallelogram. So we don't have to worry about proving whether it's a parallelogram. We just have to prove whether this parallelogram is something better. Are we okay with this? Right, so we're going to see 3 parallelograms, and we're going to determine, are these parallelograms anything special? Can we label them as a rectangle, rhombus, or is it a square, or is it just a normal parallelogram? So what about this first one? What is that?
Rectangle.
Why do you know it's a rectangle?
Because it has a 90-degree angle.
It has a 90-degree angle. And based off of our rules about parallelograms, that makes our opposite angle 90 degrees, and it makes our consecutive angles also 90 degrees. So we have 4 90-degree angles, so it is a rectangle. Is it a square?
No.
We don't know. We don't know any lengths of our sides. We can look at it, and it looks like it's not going to be a square. So we'll just, for right now, okay, yep, we have a 90-degree angle, and that's all we need. Oh, my lines disappeared again. Sorry, I had to erase some things. Is this, what is that middle one?
It's not a rectangle, rhombus, square. Yeah.
So it's not a rectangle, not a rhombus, or a square. Why not?
The adjacent sides
Our 2 adjacent sides are different lengths, meaning it can't be a rhombus. We don't have any information about our angles, so it's not a rectangle. And if it's not a rhombus or a rectangle, or both of them, it can't be a square. So it's just an average parallelogram. Nothing special. Still a parallelogram, but just a parallelogram. And then what about that last one? What do you think is a rhombus and not a square?
all the sides are congruent.
So all of our sides are congruent, which we meet our rhombus criteria. But why isn't it a square? Why isn't that next level up?
Because the angles are 90.
Our angles are 89 and 91, so they're not actually 90-degree angles. They're close, but they're not quite. So this is technically a rhombus and not fully a square. But for the most part, just being able to identify what is what we want to look for, or being able to identify what is my rule about my rhombus? What is the rule about a rectangle? What's the rule about a parallelogram? And so we still have to remember, though, with rectangles, if I have diagonals in a rectangle, I still know they need to bisect each other. I still know that my rhombus has opposite angles being congruent. They just have that additional fact to that. So let me take a drink really quick. Thirsty. All right. So we have a shape here, the parallelogram. We want to figure out what would we need x and y to be in order to make this a rhombus. So how would we be able to set this up to be able to figure out what those x's and y's would need to be in order to have this actually turn into a rhombus and not just a parallelogram?
They would all have to be the same.
So all of our sides would have to be the same length. So how can we do that? Okay. So what should I set equal to what?
Like your x's, y. You know what I mean? The x, the other, yeah. What would happen if we like set them all to each other?
What would happen if we set them all to each other like this?
You get into different variables.
You can still solve it.
Like to solve it, like instead of doing two equations, just one big equation.
So I would solve for my x's first and figure out what one is, and figure out what a full length is, then you could solve for the y first. Solve it separately right now. And then in order to check what they all are to make sure they're the same, plug your x back in to figure out what the length of these sides are. Plug your y back in to figure out what the length of those sides are. And then if all of your sides are the same, then you know you have something correct. But right now, see if you can solve for what your x and your y are based off of our knowledge of the wrong.
Well, that's
38 was
oh,
our
never mind, sorry. X is 2
Yeah, that's not very
and
much.
Y is 3.
x is 2 and y is 30.
Yep.
Okay. So you're able to combine your like terms, solve for your x. And now if you take 2 and 30 and you plug it back into our equation, what do we find for the length of all these sides? 30.
Yeah, that was where that was.
Okay, good.
I was like, yeah, somebody's like, yeah, I don't know.
So anytime you want to check your answer, just to make sure you're correct, we know all the sides need to be the same, so we can plug it back in to find the actual side lengths, and we found 38 for everything, so it works. Good, good. And that is how we can use our rule of a rhombus. What is this situation? We have some diagonals on there. So we want to find what the value of x would be in order to make this figure a rectangle. Now thinking about our knowledge of rectangles, what do we know?
4 right angles.
4 right angles. Now how can we use this information and our knowledge that we need to have right angles in there to help us solve to make sure this is a rectangle?
And we add them together. Like, should we add the 2 angles together like it?
So we know that both these angles, we have this little one in here and this longer one, together they have to get a 90-degree angle. So if we take 5x plus 25, we know that together with 7x plus 5 needs to equal a 90-degree angle. So we can take 5x plus 25 plus 7x plus 5 and set it equal together to equal 90. And from here, we just have to combine our like terms. This is similar to the consecutive angles have to be supplementary, except we know it just needs to make a 90-degree angle for this one. So combine your like terms, then from there, it's just a 2-step equation. So we combine our like terms, we get 12x plus 30 equals 90, subtract the 30, and then 12x 60, divide by 12, divide by 12, and x equals. Once again, if you really wanted to check to make sure this was true, plug 5 back into both of these, add them together, make sure it equals 90, and you got it. Good. So you were able to use our knowledge that rectangles have to have the right 90 degrees in their angles to solve this. Once again, the main thing I'm looking for is how can we use those properties. How can you use that property to set up that equation? Solving the equation is just the action. About this mess. What shape is it looking for?
Square.
Square. So what do we know about squares?
All the same size. Yay.
Okay. So how can we use that to help us?
Find a rhombus, something like these are like rhombus triangle.
Would you 7y plus 13 equals 90?
So we know it needs to have a 90-degree angle, right? So we know this expression has to equal 90 degrees. So 7y plus 13 equals 90. Good.
And x plus 13 and y plus 9 have to equal each other.
We know our sides have to be the same. So x plus 13 equals y plus 9. Good. But the thing is, this has two variables. Can I solve that?
Not that big enough.
Yeah, you don't have to look at it.
So we're going to have to solve the y one first. And then once we get y, we can plug it back in. Good. Let's see if you can find one. Let's see if you can find. So, what did we find for our y for this problem?
11.
So you're able to solve this, and we got y equals 11. From here, we were able to plug 11 back in, so we had x plus 13 equals 11 plus 9 is 20. And then we can solve for x. Once again, if you wanted to check, plug your x's and your y's back in, make sure everything works how we want it to work, and make sure we get all those values that we're looking for. And so, once again, the main thing for this part is just being able to remember what is the property, what do we know about rhombuses, what do we know about parallelograms, what do we know about rectangles, and just using those properties to help you find the situation, or using those properties to help us show, is this a shape, is this not a special shape? So we're going to look at one final sort of challenge question. More challenge question. We have a graph. So they give us 4 points. That's going to form a quadrilateral. We need to figure out what type of quadrilateral it is. So we have -4, 2, 5, 0, 3, 1, and -1, -2. We have our 4 points. We can get next.
Find the angle.
That's really.
We were trying to make my life straight.
So it looks like a square. Now, how can we show it's a square? What would we need to show?
Sideways. Yeah, right.
So see how many boxes each line takes up.
So we'll have to show it has congruent sides and 90-degree angle. Or at least a 90-degree angle. Okay. So how do we find the side lines on the graph?
Distance from like point to point, or like.
Well, is this a whole trying to count this like full box? What is this? Is this one box?
Let's do one. Do like -2 that one thing we used to do.
That kind of stuff, like slope.
Yeah, up and then
That's supposed to be. Like y2 minus y1 over x2 minus that kind of stuff.
Right.
Try to feel yes, that stuff. Yeah,
Okay.
I just did like the entire formula for that. I just usually love.
So what? I'm increasing by 3.
I'm bored.
I'm going over by 4. How will that help me figure out what the length is?
Like an end group. Oh.
So that will give me the slope of the line. So I know the slope of my line is 3/4.
I know that makes sense. Line goes over supposed to be like this.
But what will tell me the distance?
B.
What type of triangle do I have?
Alright, triangle, I'm assuming.
Okay.
Oh gosh.
What can we do to find the missing side of a right triangle?
something.
A squared plus B squared equals C squared.
We can use our trigonometry. A squared, or not trigonometry, but Pythagorean theorem. A squared plus B squared equals C squared. So Pythagorean theorem, that's 3 squared plus 4 squared equals C squared. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So we take the square root of 25, 5. So we know the length of this side is 5.
So we end up counting 5.
Well, to show that. We don't know that. Because we don't know it's a square yet. We're trying to find it. So if we look again, this side is 3, this side is 4.
Well, then share that's what we say thing.
So 3, 4, that should be the same. So this will also be a 5.
Wait, but I said just do -2 to 3, point.
That's 5.
So one more time.
The point is that.
This one.
No, I'm out. No, I'm out.
So at the very beginning of the year, it would have been in September, I think, we talked about distance formula, where you take like the difference between the 2 points, and then you square that, and then you take the difference between the x's, square that, we add them together, take the whole square root. That was derived from the Pythagorean theorem, it was the same thing. So, from distance formula. So that would also work. Okay, so we showed 2 congruent sides are the same. So we have one thing is true. We know it has congruent sides. So it's at least a rhombus. But how can we show that it's also a rectangle? How can we show it has a 90-degree angle from there?
I mean, those things are like, you know, like the triangle things that are like 90 degrees. When they sort of like correspond or something like that.
Yeah, like when you made 2 triangles.
Yeah.
You don't know any, because
Somewhere
we don't
related.
work in an equation.
Yeah, like there's.
Can't we make a triangle?
We do know these are 90 degrees. But that doesn't tell us anything necessarily about this angle.
What? Because if 2 right angles is 90, that's 180, and we have the 2 sides, so it should be the same for the other. And if 2 of the sides are 5, then the other 2 should be 5, right?
So we know these 2 are 90 degrees. But 180 would be everything inside this triangle. That still doesn't tell us anything inside
Are they like a curve?
So they don't bisect.
Are they like a
What do we call 2 lines that cross and make 90 degree angles? Parallel are 2 lines that don't cross.
I want to say like
Non-perpendicular.
Perpendicular. So 2 lines are perpendicular if they cross and form a 90-degree angle. So we had those like perpendicular bisectors when we were doing our construction. They crossed in the middle and they formed a 90-degree angle. If we can show these 2 lines are perpendicular, then we can show this is a 90-degree angle.
How do we do that?
We did it back in October.
Do we have to work out the what are those things called, compass or dragon?
No, we're not using compasses. So for showing something was perpendicular, we looked at the slope of a line. So we found one slope to be 3/4, they had a rise of 3 and run of 4. What's the slope of my second line?
A run of 3 and then drop.
So it's -4 over 3. So 3/4 and -4 over 3, what do you notice about them?
They're
The
like,
opposite.
they're
They're opposite, so one's positive, one's negative, and they're reciprocals of each other. Does this make them perpendicular?
Yeah.
Oh, yeah.
Yeah, so this is what we showed in the past. In order to show 2 lines were perpendicular, they had to have reciprocal slopes. So we had to look at the rise and the run. If they were flipped versions of each other, one was opposite, one was positive, one was negative, that made them perpendicular. So this is, in fact, a right angle in here, which means all of these other ones are also right angles, which means it is a square. So that is a challenging question. You have to use the graph, you have to use what we know, we have to use what we learned in the past, and sort of relates a lot of things back together in order to show. So they call this coordinate geometry when you have to show geometry on a grid. It sometimes comes up on your state test, sometimes they might ask you this, sometimes they might just ask you just normal stuff, or hey, is this a rhombus? Or sometimes they might give you the points and say, hey, is this picture a rhombus? So we also need to remember how we can relate our graph information to what we actually know, how we can show this program. Tough stuff. And that's what we're going to call it today.